All right, we're going to do some comparing of two scatter plots with linear models. So this first is graph A, noted here. And let's just look at this. We're going to answer two questions about it, independent variable and dependent variable. So when we're looking at this, recall and just remember that independent is down here. So we see the independent will be the year, and make sure you put since 1971, right? That's independent. Dependent is here, average ticket price in US dollars. So independent variable, years since 1971. Dependent variable, money, yeah, average ticket prices. Okay, so we go to B. Now this is showing the same information, but look at the difference. Here it starts at 0. In this graph it started at 1971. So our independent variable is still years since 1971, but the difference is when you're talking, okay, time out. When you're talking about this one, you see how they just have years. They don't have 0, 1, 2, 3. So when you're putting in values for x, this value for x would be 1971 because that's what's on the graph. In this one, if you wanted this value here, the value is 0. So 1971 is represented by x equals 0. So you really have to pay attention to your labels on your axes. But in terms of your independent and dependent variable, we still have years since 1971, and we still are talking about money, average ticket prices. Difference in the graphs is the labels of the independent variable, as we were just talking. Starting with a year, whether or not you put a year into your model or a value like x equals 1, 2, 3 makes a difference. So we're going to use the linear model from graph A and B to do the average price of a movie ticket. Now, you can look back. We're going to do A first. The model in A is y equals 0.1549x minus 30411. And remember that in graph A, they had the actual years on the bottom. So if we went 1990, we're just going to simply put in 1990 into the model. Okay, and when I do that, I get a value. Let me flip the page so I can see it. Where's that? $4.14. So in 1990, the average ticket price was $4.14. Now, in letter B, our model was y equals 0.1549. Notice, same slope, but a different y-intercept. All right. So in graph B, 1971, let me change colors here. 1971 meant x equals 0. So 1990 is 19 years later, so we're going to use x equals 19. So when I go to this model, I will take y equals 0.1549 times 19 plus 1.2012. That value gives me $4.14. Are the answers the same? Yes. So does it matter which one it is? And the answer is not really. The only real difference is that this graph B is an actual, it's a better representation because the y-intercept has an x value of 0. So in 1971, this is more accurate in terms of a mathematical graph because we have a y-intercept that is accurate because it is accurate at x equals 0. And you can see in 1971 the average ticket price was $1.20. We can see that in our model. Whereas in part A, our y-intercept, I mean, you might say, well, it crosses the y-axis there. Well, that's true, and that's at 1971 the ticket price is $1.20. But the y-intercept in the model is when x equals 0. And in this graph, when x equals 0, that's the year 0. Which I don't think any of us were alive then, but the average ticket price would have been negative $304. So you can see how the model, it's accurate. If you type in 1971 into the model, you're going to get 1.20, but it doesn't show you that accuracy in the model. So that's just kind of the difference between these models.